Hey everybody, thanks for checking out the channel. This is another installment of What's Up With My Rig Today. I've made quite a few changes and enhancements, so I thought I'd share with you what I've been working on and maybe you'll get some ideas for your rig. The first thing I did was I finally figured out how to make my hood attach. Now this is a Capra body and I've chopped it about 20 millimeters narrower, and I also shortened the hood to make it look more proportional. And the problem is there were no longer any places to mount this. So it took me a while to figure it out, but I eventually landed on this idea. I have my own front bumper here. It's a carbon fiber tube. And what I did is I made a slit across the back and the hood plugs into it. Just like that. So no bolts, no nothing. And that's how this hood is sitting in this bumper. Pretty clean, only 2 exposed bolts. I'll probably switch these bolts to match these bolts. These are actually nuts on the top. These are bolt heads. I kind of want them to look the same just because that's how I am, so I'll probably make these match. This is the final version of my custom chassis. No plans to sell it. I just made this for myself. I originally started with a poised chassis, which was one of the very first forward, highly angled skid designs out there, and I just really fell in love with it. But I wanted to push it even further and do some things that I couldn't do with a stock poised. So this is my original prototype. Worked out great. So then I cut it out of 2 millimeter thick carbon plate, or I should say I had a friend of mine cut it. You can get these cut yourself at Send Cut Send. They're surprisingly affordable. If you know how to use CAD and you know what geometry you want, you can probably make your own chassis cheaper than you could buy one. I only use 2 millimeter thick carbon because I have quite a few cross braces. Most carbon chassis are 3 millimeter thick. And I also reinforced my chassis across the top here, so it's triangulated. I don't know why so many people leave this open and don't put a truss across here. I have seen some chassis break down here. I've never seen a poised break, but I've seen other similar chassis break down here. And to me, it makes sense just to have a strut connecting that. So that's what I did on my chassis. I knew exactly where all my links were going, so I didn't drill too many extra holes. In fact, in the rear, I only have 1 hole for my shocks. And in the front, I did leave myself 6 holes to mess around. And I have a couple holes for my upper link, but for the most part, all the holes are exactly where I wanted them. The other thing I did is I finally got around to making some sliders. And I'm pretty stoked with how these turned out for the first version. Again, these are custom made specifically for my one-off chassis. They bolt right here on the side. Because my skid is a narrow 55 millimeters, I can put my links on the outside and it's really clean. I've also got the carbon protected by both the skid overlapping and the sliders overlapping. So this is all one smooth flat surface that protects the carbon at least up to here when the carbon comes out the back. So pretty stoked with how those turned out. The other thing I tried to do was match the angle of the side panels as accurately as possible, and I got it pretty close the first time. The other thing is I've got it right up against the edge of the slider. In my opinion, you want the sliders right up against the bodywork. It should be a perfect match, no gaps, no seams, no transitions. And I'll probably actually make this slider a little bit wider next time, so it sort of puts a little bit of pressure on this. I think it could be a little bit tighter, but pretty happy with how well this fit the first time through. Really like the slider action. I'm also super happy with my skid. Look how thin this is. The transmission is only 3 millimeters off the bottom surface. That's crazy. Put your center of gravity super low. Your transmission and your motor sit really, really low. So I'm pretty stoked with how that worked out. I also built a newer version of this bearing carrier. I cut it out of a square piece of carbon, and I left a little bridge here to keep it from bending, to keep it stiff. And this is one of my earlier bridges. I just glued 2 L pieces of carbon to a flat piece of carbon. And that's really light and really strong. Then I printed my own plastic carrier. My first carrier was short like this, and I went back and made a longer one. I'm using a titanium axle from, some deluxe transmission. I don't remember which one, but they sold me the axles alone. They have a short axle and a long axle. This one worked with the short axle, and I wanted more clearance, so I made a longer version. And I also wanted a lower profile. A lot of bearing carriers use a 13 millimeter bearing, and I used an 11 in my last version, but I wanted to make it even smaller. So what I did is they do make one smaller size. This is a 10 millimeter outside diameter, and I stacked 2 of those in this side. So this has 2 small bearings here, one slightly bigger bearing here where there's clearance, and that makes for a really compact, low, small, high clearance, low CG bearing carrier. And I'm pretty happy with that. Here's what it looks like. I got the angle almost perfect so that the drive shafts are as straight as possible. And you can see from the side, I've got lots and lots of clearance. And it's almost entirely hidden by the chassis rails. Very, very low profile, high clearance. It's exactly what you want. I also made a new skid for my rear servo. I didn't want to get it hung up, so I've got this lead-in ramp that protects the servo, and I've got a carbon plate on the bottom of the servo, which I had before. But I made this a bigger diameter. Previously, I had this, I think it was 1-inch diameter tube, and I cut a quarter section out of it, glued an L to it to make this little guide, but I wanted an even shallower lead-in, so that means I needed a bigger diameter tube to start with, and I found this for under 20 bucks. It's actually a camera extension pole, and it's made out of really nice thin carbon. This is almost 1.5 inches in diameter, so I was able to get a bigger diameter section cut out of it, and then that is taped on the front of my servo. So I've got a nice smooth lead-in to avoid hanging up on my servo. Pretty happy with that concept, and I really like how the larger diameter lead-in ramp is working. Another big thing I did was I changed my front servo design. I have a custom servo mount here, and my servo is at an angle like this so it can push forward as far as possible. I don't know why most companies just put their servos perpendicular like this. It takes up a lot of space this direction and can interfere with your motor and your transmission, so I have mine tilted and pushed forward as far as possible. That, of course, puts more weight forward. The problem I was having is because this has been getting so low that my hood was interfering with the servo, which is why I have this protector on here, is because the servo arm was rubbing on the bottom of the hood. So in order to get my body lower, I had to move my servo down. But my servo was already flush with the bottom of the axle, so my only option is to go with a shorter servo rather than a full-size servo. So I'm testing out a low-profile servo on the front to allow me to sit it lower. I made this carbon bracket, and there's another plastic piece underneath that supports it, and the servo sits right in there. It's a pretty tight fit. It's all very, very custom optimized for this Vanquish axle, but I'm pretty happy with how low and forward it is. I tried a Holmes 650 LP servo, and unfortunately I immediately blew it up. So I've replaced it with a Reefs 900 LP. This servo is supposedly made by Reefs, and I couldn't confirm that anywhere, but I believe that to be the case because the packaging is identical, even down to the stickers that hold the case shut. More importantly, this wire is the only wire I've seen that's this thick. So I'm pretty confident that Reefs and Holmes are made by the same people. Nevertheless, I managed to toast this on the very second drive. So that is garbage. Low profile servo is about 72 grams and a full-size servo is about 90 grams. So you're saving not quite 20 grams going between the two, but that's a lot of grams. And the difference in height is about 10 millimeters. So I really am interested in saving this height. And the power on these new LP servos from Reefs and Holmes are quite high. I'm assuming it's going to be high enough for my application, but we will see when we get out there. I've also got my speed controller taped to the back of my servo, and you can see it's real close to the motor. I left about a 5 millimeter gap between the motor and the speed controller and the servo and the front axle. So my skid is as far forward as you can possibly get it. I guess I could get one shorter motor like a Yellow Jacket or something, and that would allow more clearance for the motor, and then I could move my skid a little further forward. But my links are already so short, I'm not sure that making my front end any shorter is going to have be possible from where I am right now. On the topic of shocks, the other thing I did was made a really, really short shock. I got Deluxe to send me some of their offset caps, put those straight on, and then on this side I'm using, it's a Traxxas rod end. It's really, really short, and this shock is only 55 millimeters, which is quite a bit shorter than the standard Deluxe ultra short shock. It's purely because of the ends. Now you could go even shorter with this end cap, but in my case I didn't have the clearance for this cap. I needed to use this one. So look how crazy short that shock is. The shock that's actually on my rig has the internal spring. So I used a longer body to get that in there. And what I'm running on my vehicle is a 60 millimeter eye-to-eye, which is really short. It has 22 millimeters of stroke, which is really long, and that includes extra clearance for the internal spring. So you can build a really super short shock with these new end caps. And there's no reason not to go short as long as you have the stroke that you want. Put on the shortest end caps possible and keep that weight and shock down as tight and compact as possible. I've also got my custom weight hangers on here. There's a video that explains what I did here. This weight is super low, super heavy. It uses cube-shaped tungsten weights on the inside. The center of gravity is actually lower than a deluxe loaded dice wheel, and it works with standard wheels as long as you have a high clearance rim. This is a 2.2 Crawler Innovations rim. I love these plastic rims. They're super durable and so light and so cheap. And I believe they have 53 millimeters of internal clearance. And there are other beadlock aluminum wheels that have 53 millimeters of clearance. So you could run these weight hangers on other designs. And I have sold a few to people that wanted to use them. They're 3D printed out of stainless steel. And I believe that Deluxe would like to sell these at some point. In the meantime, you can hit me up on my Facebook page, Boomslang Suspension Sus, same name as the channel, and we can get you squared away if you're interested in testing out some of these crazy weight hangers. Another thing I've started doing is using a short servo horn, and that actually puts less leverage from the wheel against the servo. It also gives you less throw, but if you've got a programmable servo, you can program your throw. So this is sort of a way to add some built-in protection to your servo. And on the rear steer, I'm actually using the lower hole, which I think is 16 millimeter difference. The outer hole is 20 millimeter difference. But again, that increases your power against the wheel, which conversely reduces the wheel's power against your servo and amplifies the power, especially when you're using a small servo, and at the same time amplifies your protection. I've also got my negative spring, internal spring deluxe shocks on this. You can check out my other video to see how I did this. A lot of people absolutely despise internal springs, but I think it's a pretty great concept, and it keeps your chassis down at full compression or full droop and still gets full articulation with very little effort, but keeps your shocks from extending. And I've got the same thing on the front. I've got, see, it'll droop all by itself, but the chassis gets sucked back down. So the weight of the axles will cause it to extend. It's not so powerful that it prevents that, but the chassis will draw itself back down. So when you're climbing up a steep hill, it holds the front end down. I've got stiffer springs in the front and heavier oil in the front. I've got 20 weight in the front and 15 weight in the rear. I may actually go up a little heavier in the rear. I may go 20, 25. So there you have it. Servo mounts, custom shocks, whole bunch of carbon pieces. That's where I'm at today.